Hello, everybody. Welcome to my live stream about spec-driven testing this time. This is the second live stream. We had one last week at the same time about spec-driven development. And what we created was a Vaadin application with Juke, and we use Cloud Code to do that. And let's see how this looks. So that's the competition management use case that we created. And here we are able to add a competition. For example, let's say it's called demo. It will happen on Saturday. It will be in Bern in Switzerland. And we can save that. Sorry, a breakpoint here. And then it will be saved, usually. Let me check again. And now it's saved. And we can edit that or we can delete that. So that's what we did so far. But we didn't do any tests. So I think we need some tests. And that's the topic of today. When we look at our application, we created a use case, this one. And this use case was the input to create the implementation. So we can also use that input as the test input because we have the use case specification with an ID, we have a use case name, we have actors, we have the goal of the use case, we have some preconditions. We don't have authentication in place currently, right? So we just rely on the application without login. And then we have the success scenario. So we go to the competition management interface. The list of competitions are displayed. And then the administrator creates a new competition, adds the information, and finally it stores it. And we have alternative flows like editing an existing competition or deleting a competition, or if we have validation errors or cancel operation, stuff like that. And this input, because it's very precise, we also have business rules, by the way, so the competition name must be unique, competition date must be valid in the future, for example. We also have data validation, how long the named location can be, something like that. And based on that, we can also create tests. Now the question is, what are we going to test? And there we could have a look at the code. So for example, we will see that we have a competition service, which more or less is kind of a CRUD repository that can find and save and update competitions. But the main thing that we have is the competition view. So we have this view here, and what we would like to test is the UI. But now, you know, if you do UI testing with normal frameworks, either you only do that on the front-end side. If you use Angular or React, you could do tests there, and you will mock the data. But we are on the server side. We are Vaadin. So we don't have any front-end only tests. So the question is, how can we do that? And for that, I created a little drawing here that shows the architecture of Vaadin, because that's something that we need to know to be able to find the best test strategy for that. And here we have a separation of browser and server. And as you can see, the text field and the button, for example, our create button or the grid, or in the form we have text fields, exist on both sides. We have on the server side, we have our Java classes, text field and button that we create. So that means on the server side, we have a component tree. But also on the browser side, we have this component tree because every Vaadin component is a web component that then will live on the browser side. And as you can see, if I call set value, for example, on a text field on the server side, this will be sent to the browser, and the browser will display the value in the text field. On the other hand, if we click on a button, the click event will be sent to the server, and the button click will also be clicked on the server side. And because of that, there is a way to test Vaadin applications like you do when you, for example, test Spring Boot applications. Because with Spring Boot, you may know there is mock MVC. That's an environment that does not start the Tomcat web server. This just tests in memory your REST controls, for example. And there is exactly the same concept. Martin Vishny from the Vaadin team created a framework that's called Karibu Testing, and he calls it browserless testing because we will only test the things that are on the server side. So we will not have any browser interaction to do the tests. We just test the server. That has one huge advantage because if we just test the Java side, this will run as fast as an integration test. So we can run, in my current application that I'm building, we have around 1,200 Karibu tests, and they run in 45 seconds. So they run in the same speed as integration tests. But we also need somehow maybe to test the browser side. And for that, let's go to my AI unified process. And if you remember the diagram, we have this green part of the process. So the blue part is developing a vision, gathering requirements, defining test strategy. We will then end up with the requirements catalog. And now we want to create acceptance tests. So we want to test if the requirements are all implemented. And for that, we need acceptance tests. And this could be something that we would like to do on a browser testing. And that's why we could, for example, use Playwright. And I have an example for you with Playwright. So the green parts of the requirements, so to say, or the acceptance tests would be Playwright. I would do less end-to-end tests because they run very slow. For example, a regular Karibu test, so a browserless test, could run in half a second. But the same test on the browser side with Playwright could run for like 5 seconds. So it's way faster to do a browser test, so we will have many of them. And these are the tests that are here down in the orange section where we have the code generated already. So we have code that works. And now we want to generate the tests to do that. And we have Catherine here. Hi, Catherine. Welcome. And now we want to start with the tests. Now, the question is always, do we need mocks or not? And that's kind of a problem when doing tests with AI, because there are probably so many examples where people are using mocks to mock, for example, the repository layer, that this is kind of problematic for your tests, because this will not test the whole application. And if you look at our application, we have just the UI and the database, and there's some service in between that uses Juke to create SQL queries. And most of the validation will be in the UI side. A lot of validation will be in the database as well. And so the Juke code is just a glue code between our view and our application, and we have very little code actually to test. And that's why I also created blog post about that topic. I can paste that in the comment so you can see it. And I try to describe why I don't use mocking frameworks. I don't say that mocking frameworks are bad, like Mockito, for example. They may be helpful if you want to mock external system and don't want to call that. But in most cases, in business applications, the application doesn't make sense without the database, so I don't mock the database. But I use test containers. We've seen that, right? We have the configuration. By the way, yesterday I updated to Docker Desktop, which comes with Docker 29. And now the test containers Juke plugin is no longer compatible because it uses test containers 1. And you need test containers 2 to be able to use Docker 29. So I rewrite kind of my code. If you want to have a look at the example, you will find that in the POM XML. So I do it a bit differently, and I update it to test containers 2. Now, what's the problem with mocks if you use them? The problems are not the mocks. Usually the problems is how you write the code. So that means, for example, if we have an application like that, it's an order service with an add item method, we will have a lot of database interaction before we can actually execute the business logic. So that means we check if the purchase order exists. Here we try to find the product. And if this works, then we get some product price configuration because we have some configuration depending on the quantity the customer wants to buy. We have discount prices. And then inside this Lambda function here, we actually do the business logic. So from line 16 to line 23, that's the business logic. And then we store the item and return the order item. And for that to test, if you only want to test the business logic, we need mocks. So we need a mock for the order repository, a mock for the product repository. And that's a bit of a problem because, as you can see here, we add a lot of lines just mocking code to execute the test. But you could go ahead and just extract the price calculator. And this will give you then the possibility to just instantiate the price calculator and call the method. And this method then will be functional because everything that the method needs will be passed. So we have the price, for example, and then some configuration, and it will return a price. So this will be deterministic. So every time you call calculate price with the same parameters, you will get the same result. And in my application, if we look at the use cases, again, we have these use cases. So we have, by the way, for those who were not at the last webinar, we are building a track and field competition management application. And we have a lot of management stuff like categories, athletes, clubs, competitions. And we only have, in fact, one use case, that's calculate points. That is really business logic. We have some logic to generate a ranking list, but the business logic that we really have here is calculate points. And so we need to isolate this functionality. We could create the points calculator and then use that or create that in a functional way and then test that without the mocks. But all the other use cases simply don't make any sense without the database because they read and write database, and that's the integral part of this use case. So that means we want to start with the Karibu test for our application, that we can create a test, and that will be a test for the view. And first of all, if we go to the test directory, you will find a class that's called Karibu test. And this class is kind of a bootstrap for the Karibu testing environment. So in short, what happens here, so we import the test containers configuration because here we start the Postgres SQL container. I still use the latest version of Postgres. Don't do that in production because you don't know exactly what latest could be. And but for the demo, it's perfectly fine, so I don't have to update the demo every time a new Postgres version comes out. And then it's a Spring Boot test. And here we have an application context that has some methods. So before all the test execution, we set the default to English. So that's just convenience because I usually create applications that support multiple languages. So this time I use English. Then I discovered the routes. So the routes are the views that we have in our application. And with that route auto discovery mode, Karibu testing will collect all the views. So all the application classes that are annotated with the route. And then we do some setup before each test. We create a mock Spring Servlet, we create the UI factory, and together we can then set up the mock Vaadin. So that's not that integrated as you have it from mock MVC, but that's just this one, and you can create this base class. It's also described in the Karibu testing documentation. And then finally, after the test, we want to log out first of all, and then tear down. And this base class would also support login and logout. And if you know Spring Test, and Spring Test Security, there is mock MVC. And then you have with mock user, and you can pass or annotate the test class and define the username and some roles, for example. And here we have the same concept. We can log in a user, and this will fake the security context, and we can then test our UI with multiple logins. So that's the idea of this test, and that's integrated here. And now we'd like to do the tests. And again, I use Cloud Code. By the way, Cloud Code has a brand new model. It's Opus 4.5. It just came out yesterday, and I'm very curious what it will generate, because before I was using Sonnet, and now we were back on Opus. Now, what I also did, and I've been already showed that the last time, I use MCP servers. So let's get down here where we have it. And I have a bunch of them. I have Context 7, JavaDoc from James Ward. I have Juke, that's MCP server that I created for Juke documentation access. And I also created a Karibu testing MCP server. And this Karibu testing server has a lot of tools. And this will be helpful for the LLM to do good Karibu testing. So that means there are, for example, a tool for generate confirm dialog tests, because that's a bit special. And I also have added some examples that you can go with that. Now, the problem with these MCP servers is that they use a lot of the context. So if you look here, we have a lot of MCP servers, Karibu Testing, Vaadin, SonarQube, Juke, Playwright. They are all active. That doesn't make sense, by the way. But you see that the MCP tools, I didn't do anything, right? Already consume 67,000 tokens. And there's a lot of discussion in the AI field currently how we could do that, because the MCP servers are great, right? So you can use MCP to add information to the LLM, and that's a great thing, but they consume a lot of token. So there are other ways to do that. For example, Cloud Code has skills, so I could add the documentation to skills, or what some people are trying now is to add or to hide the MCP calls behind some tools that they create. So maybe some TypeScript code you can have in Cloud Code that calls that. But it doesn't matter for the demo, just as an information, because sometimes people are curious about the MCP stuff. And then, as last time, I have some commands, and there's a special command for Karibu test. And here we have some kind of a prompt. We want to have a Karibu test for a use case, and I can pass the use case as an argument. That's here then taken into account. I don't use Mockito. By the way, probably it is not even able to use Mockito, because I excluded the Mockito dependency. Then when it comes to test data management, I usually do that like this, that I create flyway migrations for creating test data. And they go into source test resources in the DB migration folder, and then we can use that. Then we have the directive that it should use the data from migration and not use service repository DCell context to create that. Then we should also have a look at the data that it will be deleted at the end. we could tend to add the transactional annotation to a Karibu test. And this would work because then we have the transaction boundary at the test level. And if you add a transaction annotation to a test method or to a test class, this will cause the transaction manager to roll back after the test. But that's not correct, because we are doing UI tests and the transaction boundary in that case is on the service level. So we shouldn't mix that, and that's why we shouldn't use the transaction annotation. Then I want to use SRJ. I also gave a link to the documentation, but it can use the MCP server as well. And what I also did is I added an example here in the prompt, because that's very common use case. So here we have a completely different view. That's a copy from another project. But this shows how Karibu testing works. So you can navigate to view, and then we have a class called locator_j that has these methods that start with an underscore. By the way, the method starts with an underscore because Karibu testing is written in Kotlin. And if you use Kotlin, then you have extension methods. And so you could directly call grid underscore get in Kotlin because underscore get would be an extension to grid. But we are on the Java side, and therefore we have this getter on the locator_j class, or we have special classes like grid kt, so that's the grid Kotlin class, where you can ask for the size of the grid, or we can select items in the grid, or we can get the cell component, because when we look at our example here, and let's create another demo, ABC, like so. We have that, sorry, there is still a bug, but we don't care. XYZ. And we save it, and here these buttons edit and delete are in a component column, and that's a bit special how to get that. So there's a method get cell component, and then we can get it and filter for a button, filter for some text, and then hit the click event. So that's why we have here some examples. And that's it for the setup. And now we can go ahead and try it out. So let's call Karibu test, and we have the UC001. And now we wait for the test. Now we can have a look what this does. So this will take a while because it will now create a plan. I didn't ask for a plan. I just said, do that, please. And now it's looking for the implementation. It will look at the competition view. It will look at the existing data, the database structure, and then it will create a plan. Hopefully we will see that. So it will it checks also the history, and now it checks some test data that has been there. So maybe I should start it from scratch, because now it looks at the Git history. And now it looks at the use case. It tries to understand the service, the competition view. Now it reads the use case, checks out the database tables, tries to find the Karibu test, as you can see here. So now it knows what to do. And now it starts to create the view test. And then it will look at all scenarios, so all the flows, the main flow, the alternative flows, and tries to figure out exactly what to test. And now it starts to create some test data. We have 4 competitions that it creates, different states. And now it starts to create the test. So that takes a while. So testing takes longer than the actual implementation usually, and it's also more difficult than the implementation. So in my opinion, generating tests with AI works very well, especially based in spec-driven development, where we are, in my case, the spec is a system use case. Then the implementation is pretty fast. But generating the tests, because it has multiple flows in the use case, this takes some time. And what we do now, sitting here and waiting for the test generation to end, is usually not what you want to do. So usually, as I also mentioned last time, I use Git work tree that allows you to check out multiple branches in a single local repository. And so I could start the test for a certain use case and continue with the next use case and do the specification already, or review the specification, or review the test again, something like that. And now it's already running the test. So as you can see here, it starts to run the test. Hopefully this will be successful. Now it sees that there is something wrong with the confirm dialog. He has an issue for the delete button, and now it uses my MCP server. As you can see, it calls the tool generate confirm dialog test, and he's looking into how delete button should work. I hope my MCP server will not fail, because it's in a very experimental state currently. So it works usually, but sometimes I have some issues. But that should be fine. So now it had an issue, I think. It didn't find that here. Okay. Now it's running the tests again, and maybe we can have a look at what's already generated. So here we find the test, and we can review that. So it's already looking good, because it's using the Karibu test. It does a cleanup because it stores here the created competition ID. That's probably not too bad, but not exactly what I wanted. Because if you remember the prompt from the beginning, I said don't access a service repository or DSL context. Sorry, that's the wrong one. That's this one. Make here, don't use service repository or DSL context. And that's not exactly what I want. But it at least deletes the test data after completion. But this could be done with the UI, or should be done with UI, because there is a delete button as well in the UI that it could use for that. And then what else do we have? Should display grid with test data. So here it checks if the data is there. So if we look at the test data, maybe we can see that we have 4 competitions, and it checks if these 4 competitions exist. Then it checks if it can open a dialog. I mean, that's a test, yes, but that's useless, because probably this also works when it does a regular test to edit the data or create the data. So this is probably useless and can be deleted because it's duplicated. We will see. And then we have some deprecated methods. That's because Karibu testing in one of the latest versions changed from with caption to with label or with text. So the button would be with text, and the text field and the date picker should have with label. And then we have a test that actually does something. So this sets the value. That's correct, because here we have the set value method from Karibu testing, and the click method. That's very important, because we could also click on the button directly, so on the button that we get from Karibu testing, but this will not take into account that the button can be disabled, for example, and this could be an issue. And the same is for set value, because the text field could be disabled or read-only, so we cannot call set value. And then it checks if the grid has 5 rows, and then it checks if the new test competition was created. So here again, it uses the Juke DSL, so it executes a SQL statement to access the database. But this could also be done via the UI, because it can ask the grid, give me the new row, and then check if the content is what is expected. So this worked very well. And then we have a bunch of other tests that we don't look into. But I think we can already run that. Let me see. It's still working. I could imagine that there's a problem with the MCP server currently. And now there are some test failures still, compile failures still, because the confirm dialog has no header or is not accessible, the header. So here we have some compile errors still. Confirm dialog also has no text, so it's still struggling a bit with the confirm dialog, right? And let me see what it tries to do. It still says, okay, fetch failed as I expected. So I still have some problems with the MCP server, but I will fix that and check that. So now it goes to the confirm dialog and checks how this works. And so he can then access probably and get rid of the compilation errors. Now let me check again. Now it realized that with caption is deprecated. That's very interesting. And now it starts to change that. That's quite surprising, because usually it doesn't do that. But now it replaced that. And I would say the test should be ready momentarily. Let me see. Now it has still issue with confirm dialog, and it asks again the MCP server. But I think we can stop here, because I think you get the idea how it works. So the important thing is that the LLM needs to exactly know how the frameworks that you're using are working. That's why I added the MCP server. But on the other hand, the MCP servers consume a lot of context, or a lot of tokens, especially. So the context window could be too small at a certain stage. And I just run that to check what the problem is. And here, yes, it doesn't find confirm dialog buttons. And that's something that we should fix. Let me check that. Line 64. Where is it? That's not that one, I would say. 64. Is this? Oh no, that's 5 now. He has issues with deleting the data. That's the problem here. Cool. But because I expected to have some troubles during the testing, I just prepared something before the webinar, and that's what I like to show you. Here we have a completely running example that worked this morning or yesterday evening. I can't remember when I created it. But if you go to the 7 Karibu test, you find a fully working test example. Right. So here we also have less tests than before because it really has just meaningful tests. And if you do that, and that's what I like to show you about the benefit. Now we run the tests. It starts test containers, and we have 16 tests for just one use case, by the way, or 15 because one is context load that is created by the Spring Boot initializer. But we have 15 tests, and they run in 2 seconds. And that's relatively fast, in my opinion. So this could be used for development. So you could use the Karibu testing during development. I also know some people who try to do test-driven development with Karibu testing. This could be an option, but the problem with UI testing is you only know how it looks when it's done. So it's very hard to anticipate how the UI could look like, which elements we could have on the UI, for example, to test. And so test-driven development is maybe not the best way. But what my example here shows is that you can directly use the same specification. In that case, this use case description to create the implementation and also create the tests. Now that's the first thing that I wanted to show you. And the second example is we want to do real UI tests. So we want to do end-to-end tests, so kind of acceptance tests. And therefore, I also created a command here to use Playwright. And for Playwright, I have also a base class for the tests. This time it's a bit different. So I also import test contains configuration to get the database. But then I don't want to use the mock MVC from Spring Boot. I want to run it against the real Tomcat. And now there are a few options. First of all, we could have a profile that starts Spring Boot application before the test, for example, and stops it after the test, and we could run that with Maven. Or here we have a different approach. I use Spring Boot test and tell I want to have a real web environment at a random port. And with the local server port annotation here, I can inject that to the local server port. And here I create Playwright. So Playwright is a tool from Microsoft that exists for Java, JavaScript, or TypeScript, Python, and .NET. And you can use that for UI end-to-end testing. So it's similar to Selenium or Cypress, but it's more modern, and it also has some auto-wait functionality that probably makes it better. And we have some launch options. For example, here I tell it that I want the Chromium browser, and I use that because this option with the headless, that I can switch it on or off, because default is it's headless, you won't see the browser, but we can switch that to false, and then we will see the browser and can also debug the test and so on. And because it's Java, I just use JUnit to run the end-to-end test. That's also very handy. And then I have an extension that's called Moppo. Moppo is written by Matti from the Vaadin team, and is kind of an extension. It also has some grid functionality to help with the implementation, and that's quite handy. And for that purpose, I switch to another branch. There's a Playwright test branch, and here I go ahead and delete that test. And the Playwright IT test, not the Playwright IT test, but my command has also an example here. So here we have example how to test. Let's do it like that. Here we have examples how to test grids, because Matti created a grid Playwright class that can be used to, for example, find the number of rendered elements in the grid, or to get a certain row or a cell value, stuff like that that you need. And Moppo also have special wait functionality for Vaadin, because Vaadin does client-server communication, as we've seen before in the diagram, and there we have to wait. So if we click a button, for example, or select a row, we have to wait until the communication happened, And that's what Mopo wait for connection to settle is doing. And that's very, very helpful. The rest is quite simple. So you have a page, and the page has a locator method. There you can, for example, find Vaadin text field. You can filter it and check if the text of the Vaadin text field, in that case the label, is of title, and then we can get the input and check the input value, for example, because the special thing about the Vaadin components is that they are web components, and the input field is an inner component of the web component where, in fact, the HTML input file is located. So that's an example test. And now we can do the same as before. So we can, again, start Claude. And this time, instead of creating the Karibu test, we just advise to create Playwright tests. And these tests now are also kind of white box tests, because if you would have a tester that, or a test engineer that would write the test, wouldn't see the application code, right? Because usually they have, for example, the use case specification, and they have the running application, and now they start building tests. But in that case, if we do it inside the same project as I do, Claude will have a look at the competition view. So it will find, for example, test IDs if there are some, or any other information about how to locate the components on the UI. It will find directly in the code. And that's a bit different, because usually you do acceptance tests without knowing the code. But now what happens here is the same as with Karibu testing, but we just use Playwright. Maybe as we wait some information about test coverage, for example, usually my Vaadin applications where I use this browserless testing with Karibu testing have all a test coverage above 90%, usually around 95. I just don't cover maybe some internals or some exception handling code, because without mocks I cannot simulate that very often, and that's very, or sometimes kind of a problem there. But the test coverage is very high because I test everything, and so the need for really doing acceptance tests that have a high coverage is maybe not that important. So you should test end-to-end tests, the general flow maybe, that you see if it works in the browser. And you can also test some special browser functionality if you have highly interactive UIs, for example. You could do that in end-to-end test, but for the rest, it's not very important. And as you can see, that was way faster than the Karibu test, because the Karibu test really had issues with the MCP server. I really have to look into that after our session. So let's have a look at what's created. And here we have some test ordering. I don't like that, because test methods should be independent. So the order could be a problem. Probably it had some issues when executing the tests, maybe. I don't know. But here, as we can see, we navigate, it waits, it gets the grid, it checks the count, it gets a row by name. It created a kind of helper method to do that. That's pretty nice. And then it checks if the index is correct, and it checks the second one. Then it uses the button to create the new competition, fills the fields, it waits, or it presses enter, then it somewhere it clicks on the button. Here it saves. It checks for the notification card, and then it checks the grid and tries to find the created competition. So let's run the test, and hopefully this works, because it was very fast. I don't think that Claude really ran the tests, but we will see if they work or not. So the first test already passed. that looks pretty nice so far. So I didn't take the time to really look into the generated tests, right? And now we have the tests, and we can compare the time it used to execute. So we have six tests here that took 15.5 seconds. So that, as you can see, starting the browser is way slower, and we can also run that, that we can see something, what happens really. And here you can see it runs very fast, so you can't see a lot, but it gives you an idea what actually happens. And the test worked very well, especially because I added this example to the prompt that I used to create the test. So that's probably the success factor of the tests. But also here, it uses things that I don't like. So it uses no, it doesn't use the DSL context. So I think I saw it somewhere. No, it just worked. So that's pretty cool. So to conclude, writing tests could be simple, or generating tests could be simple if you pass examples. So here, if you have special frameworks, like in my case, I have Vaadin, and Karibu, not Karibu, Playwright doesn't know about Vaadin, so I have to add a helper. So this helper here in that case is Moppo, and because I created a small example, it exactly created that. In other projects, I didn't do that in the prompt, but I created a test called example test that really worked against the application. And then I told Claude to use that example as the example for that. And the Karibu test would also work if the MCP server would work. But I'm really not sure what I want to do with the MCP server. Maybe I will also rely on more examples. So I could go ahead and create special skills, because Cloud Code has a functionality called skills, where I can define skills. And there I could add all the examples that I currently serve from the MCP server. I could serve also from the skills, and this would consume less tokens probably. And on the other hand, it will be more stable than my hobby MCP server, so to say. So with that, I think we covered all the cases. So we know now how we can create acceptance tests. With Playwright, for example, we know how we can generate tests based on the code with Karibu testing. And then we can integrate that in continuous delivery. So in my case, I usually run the Karibu tests together with the pipeline. And for the acceptance test, I have a scheduled job that runs 2 or 3 times a day and runs all the end-to-end tests, because they run way longer. So for example, I have a customer where we have very high test coverage with end-to-end tests, and we have 3 test sets that all in all run close to 2 hours currently. And you can't do that in the regular build pipeline. This would take too long, so we have moved that to scheduled tasks. Okay, so I think that's it from the testing side. Do you have any questions? No questions? Then thanks a lot for joining the webinar. If you have any questions, you can find me on marginelli.ch or on the AI App Dev. There is also a form that you can directly book a meeting with me, where we can discuss your special situation. Maybe I can help you with generating tests or generating code, stuff like that. Just book a meeting. And other than that, thanks a lot for joining, and see you next time.